All right. No matter if you've been with me for years, no matter if this is your first training with me, you guys are going to take away a ton. So let's dive into it. Welcome, guys. This is Causal Inference. This is actually part one of a two-part series. I have another more advanced training that I'm going to be giving on Causal Inference in the next couple of weeks. More on that a little bit later. This is also one skill that will help you make $150,000 or more in your career, because at the end of the day, that's what this is about. It's not about just giving you skills, but having you be able to leave here with skills that you can apply and training that you can apply to your job and grow your career. All right. Does that sound fair? My name is Matt Dancho. This is Learning Lab 89. This is brand new content. I literally spent the last 6 weeks developing the code that you're going to see today. All right. Next. Come on. Go, go, go. There we go. All right. Goal for today. I want you guys to hold the bar high. All right. So I'm going to give you one skill that can make you $150,000 or more. That's my promise. Does that sound fair? Give me a thumbs up in the chat if you like that. If you don't like that, no big deal. This training just may not be for you. All right. I see some thumbs up. Good. Agenda for today, guys. So we're going to first cover why listen to me. So I'm going to give you a little bit of background. We got a lot of new people. The second thing, though, we're going to spend the bulk of our time today on about 750 lines of code. And I'm going to go through and explain two different scenarios for a hotel booking company, a hotel company, and we're going to see how you can apply experiments and also develop experiments, which is something I found out recently this week. That's one of the biggest problems is data scientists just don't know how to develop experiments and use data to really do that. So we're going to talk about pre-experiment analysis as well. And we're going to use a little bit of machine learning. I hope that's okay with you guys. Third thing, conclusion. How to make $150,000 or more with this skill. I'm going to give you the full, end-to-end how you can make $150,000 with some of the training that you're going to be learning today. And I also have a free gift for everybody. So what is that free gift? The Ultimate R cheat sheet. What it does, it consolidates the R ecosystem of 20,000 R packages into the 100 best. Why is that important? Well, it saves you years of trying to figure out what to focus in on. That's pretty handy, right? How does it do that? It breaks learning R packages down by category. So I spent 5 years developing this. We've got different categories in there like geospatial analysis, network analysis, time series, machine learning, finance, and that's just a few of them. When you want to work in these fields, and also if you're using ChatGPT and you want to direct ChatGPT on which packages to focus on, these are the packages that you'll want to learn and what you'll want to use. Okay. You guys will all get this at the end of the presentation, but not before. So you got to stay till the end. Okay. A little bit of background in case we have never met before. Welcome. My name is Matt Dancho. It's so nice to meet you. A little bit of background about myself. I do love R. I also code in Python as well. But I've coded in R for over 10 years. And even though we're talking, about a lot of different tech tools and techniques today, I just want you to know my roots. I'm super proud of them. I love the R programming language. And how many of you guys use R? Give me a thumbs up or a one in chat if you guys are using R. All right. I'm seeing some thumbs up, seeing some ones. Woo. Okay. All right, cool. A little bit of background. I've developed this company called Business Science. I am the founder, and what I do is I train elite data scientists. So what does that mean? Well, it means that my goal is to actually help you guys if you want to become elite data scientists. And I've had a lot of success in helping students get there. In fact, I will introduce you to a few. I'm also a software developer. These are a few of my time series packages that occasionally will go around and do speaking events on. But what I really enjoy is helping students. Okay. One of the things in software development that I'm working on currently is actually really cool. So this is the time TK package, which is originally developed. I developed it in R. It's for time series analysis, but this is the students that are working on the Python version of that package. Okay. So we got Jeff Tackes. He's a senior data science manager at Kraft Heinz. We've got Justin Kurland, who is the principal data scientist at Northwestern Mutual. We've got Samuel Macedo, who is the ML engineer at Instituto Federal. We've got Lucas, who is a senior data analyst at HubSpot. We've got Plowman, who's a data science consultant, and Alex Riggio, who is a student at the University of, or I should say, Georgia Tech. So what's the common thread between these people? Why am I even talking about them right now? Okay. Well, it turns out that these are my students. All right. And I'm just shy of training 20,000 students over the past 5 years. and my students are all around the world. So a little bit of background, my students are in Toronto, Netherlands, New Jersey, this guy somewhere in the USA, and I love getting to meet them. And most importantly, I love getting them jobs. So most of my students, they do work at Fortune 500 companies, and it's actually quite shocking to me that most of the Fortune 500 companies actually employ my students. And this is what brings us here today. It's for me to help you grow your career, okay? And I do want to help you land your next job, promotion, or career advancement, and that starts with data science education. All right, so that's a little bit of background about me, myself. Today, what we're talking about here is a couple of different things related to causal inference. All right, so I have this training structured 3 different ways. So it kind of goes from beginner to intermediate to advanced. So whether you're beginner or you're advanced, you're going to learn something. And what we're going to first start off is with a little bit of the basics of testing with experiments. And this is just a framework that I really that I use, that I like. It tells me which statistical tests to and how to get to which test to use. Shocker, we're going to be using this one today, or one of these on here, and I guess I gave it away. And then what we're going to be doing is progressing into this idea of causal inference. So we can use statistical tests to help us do causal inference. We will see that today in the beginning. But we're also going to talk about how to do causal inference and some of the layers that are related to causal inference. So this is a nice table here that really tells us how to the 3 levels or the 3 hierarchies of causal inference. And the way it works here is you start with association, and you can't get to intervention until you do some associations. So we are going to be doing some association analysis today. And that's really powerful because that's what helps you develop your experiments. Then you can do you can craft an experiment and do what's called intervention. That's the next layer. And then what you can take away from that intervention is, can we assess it for a causal relationship? So we're going to be talking about that today as well. And then finally, the last stage is counterfactuals. We are not going to get to this today. Trust me, we've got a lot of content. And I think that's what the next training is going to be, is working our way through steps 2 and 3 here. All right. So who's ready for a demo? Give me a thumbs up if you guys are good to go. Again, I want to dive into this pretty fast. I am talking a little bit faster than normal because I know we have so much to accomplish. All right, here we go, guys. So this is causal inference. We are going to close your eyes. Pretend with me today that you are working with me on our data science team, and we are working for a hotel in the data science group, and we're going to be helping out with some marketing initiatives. So that's our business case study today. Think hotels, think bookings, think cancellations, think working through some of these key problems that hotels face. That's what we're going to be doing. So let me open up the code here. So we've got 3 different scripts that we're going to be going through today. So for my Learning Labs Pro members, and I haven't explained, if you're new, what Learning Labs Pro is, but that's a program that I run. This is a learning lab, and these labs get recorded, and I put them into my vault. So Learning Labs Pro members get infinite access to that vault. They get access to all the code that you see here today, all of the scripts 1, 2, 3 that we're going to progress through. And they're going to get access to all the data sets and everything. So all they need, everything they need basically to replicate this for their business. All right. The data that we're going to be working with today, there's 2 different data sets. First, we're going to be working with this hotel bookings analysis, and I'll explain more about that here in a second. The second one, though, is hotel cancellation. So we're also going to be doing a second analysis. So our company actually has us working on 2 different projects. All right. So we're going to work through those today. We do have 3 scripts. The first 2 work with that first data set, the bookings. So we're going to be doing some ad spend. We're going to be working with Google Ads. And then the third one here is really, in my opinion, the most powerful part of this presentation, because that's what's going to show you how to do machine learning and set up your pretest analysis so we can assess it for associations and really develop what we call the treatment, or what we call the intervention, basically how you develop an experiment. And this is critical to being able to do that. So make sure you stick around for all 3 of these. All right. So with that said, we're going to be working on A/B testing. I do have the second one as a bonus. I'm just going to kind of fly through the second one because honestly, it's more important for me to get to this third one. So I'll show you a little bit of the code, but it's really meant to be a bonus for my Learning Labs Pro members. And I'll explain kind of each one. So in part one, and again, this is the beginner session, we're going to be focused on A/B testing, which is a form of causal inference. All right. So we're going to be doing what's called split testing, where we take and randomly do what's called a randomized controlled experiment, RCT or RCE. And that is basically, how many guys have ever heard of that? Just give me a 1 in chat. Put a 1 in chat if you've ever heard of a split test or A/B testing. Okay. And this test is so important, because literally, if you think of clinical trials, like what doctors and what medical companies have to go through in order to get things approved for use on humans, and all that stuff, the most important stuff in the world, they have to go through what's called randomized controlled trials. Basically, they have to do split testing, and they have to compare it to a controlled data set and a treatment data set. And I think that's really fascinating, because like the stuff you're going to learn in just this first section is really the basis of that. Okay. So what we're going to be doing, again, we're working for a hotel. We are going to be doing a bookings and ad spend analysis. I'll explain what those both mean here in a second. The questions that we're trying to answer here today, guys, is does ad spend increase bookings? So meaning what we're going to do is we're going to do an A/B test, and we're going to try to figure out whether or not our ads are getting us a return on our investment. All right. So we don't know that. The reason we don't know that is because companies like Apple have recently made it very difficult for companies like Meta or Facebook or Google to be able to track via web cookies. All right. So nowadays, what we have to do is our special techniques, and I will explain a little bit more of those. One of those techniques, though, we can use an A/B test to help us figure that out. Pretty cool, right? So the first thing that we're going to do, question one, does ad spend increase bookings? And then the second question that your company is logically going to have is by how much? What was there a return on ad spend, or ROAS? That's what that term is. So the key idea here is, can we create an experiment? All right, so we have to actually do something, and we have to have a control and a treatment group, and that's what we really need to think through before we just haul off and just kind of start spending our company's money. So the answer is yes, we can create an experiment. We can work with marketing to design a Google ad for keyword searches, such as like travel to Chicago. If our hotel's in Chicago, somebody types that into Google, we should be able to target that 3-word sequence and be able to display an ad. All right. And it's basically that simple. So once you kind of figure out which keywords you want to search for, then what we can do is we can create a treatment and control. And the way we do this nowadays is by geography. So there's this thing called geo-experimentation. So because we can't use like cookies and stuff like that anymore, one of the ways that you can do it is you can assign people to get a display ad by their IP address, or more specifically, their geolocation. All right. And it's what big companies are using this, like Booking.com, like Google, Facebook, they all do this stuff. It's called geo-experimentation. And that's where the treatment is administered at the geographic level. All right. So I know I'm throwing a lot at you, but I want to give you a little bit of background and kind of explain some of the terminology. So if you hear it, in the future after this workshop, you'll know what it means, or at least you'll have heard it before. All right. All right, so I'm going to load in some libraries first. We're going to use this Infer library, which is part of the Tidymodels toolkit. The Tidymodels is one of our featured packages this week. So we're going to be using Infer in this first section. We're also going to be using the Tidyverse, TimeTK, and Plotly. All right. The next thing is I'm going to load in this data set here. So this is hotel bookings Geo-Experiment.csv, and we're going to take a look at that. So this is what that data set looks like. And let me open it up here. And I've got a little explanation up here of some of the things that I wanted to point out to you. So this data set, it's a time series data set. And we do have different geographies. So 1 to 11, 100, those might be different, think of them as like different cities. All right. And what we're going to do is we're going to group them into different sets. And some of those are going to be part of a treatment. And you'll see that in this assignment column. And some of those are going to be part of a control. Also, the period. When period is 0, that's the pre-test, or it's also the post-test. So 0 means we don't have like any ads being shown yet. 1, it means that we're in the region during the experiment where we actually have some ads being shown during that time frame. Okay. So assignment, we saw that's control and treatment. So control is the one that does not get the ads. And then treatment is the one where we do some sort of intervention. In this case, that is getting some display ads. Okay. And then the geo-segmentation was performed by geography. We'll see also in part 2 a little bit more advanced analysis that we can do with some cool newer techniques. One of them is that I'm really excited about is called GeoLift, which is for uplift modeling for Geo-Experiments. So we'll see that it's made by this little company called Facebook or Meta now. And it's a newer package that I was really excited to find out about. Bookings. Okay, so bookings is what we're trying to measure. We're trying to measure an effect on bookings, and then cost is going to be when we spend the money. We're going to have costs that were associated. So each one of these is at an aggregated level. So, for example, this date here would be for this geography during this time frame. We had this amount of bookings. Okay, for any particular hotel, right? And so on. So that's how this is structured. Okay. So one other thing, there is going to be what's called a pre-intervention period and then a post-intervention period. So post is actually when the intervention's happening. So that it's a little confusing, but that just means that there's an experiment going on between these dates, between February 16th of 2015 and March 15th of 2015. So for a month, we did this geo experiment. Okay. So let me run this. I'm going to store these in my environment over here. So I now have the bookings here. Let me actually clear out this and we'll just start fresh. So I've got my hotel bookings and I've got my pre and post experimentation dates. Okay. So when we create an experiment, for this particular A/B test, it's actually very simple because there aren't going to be a whole lot of confounding variables that we're trying to measure. We're basically saying, hey, if they see an ad, that's going to be the number one thing that causes them to buy, right? There may be, and one other thing I should mention this too. A pro tip is sometimes when they see a display ad, there's like a longer journey. For hotels, it's probably not that bad. So a lot of times when they see an ad, they'll buy right away. But sometimes when you have especially like higher ticket or bigger decisions, so things that cost thousands or $2,000s, sometimes it takes more than one ad to get them to convert, basically, to get them to say, yes, I'm gonna sign up for that hotel. So in this case, what we're doing is we're making the assumption that they will buy on the first ad. So it's basically it gets attributed to the last click. All right. All right. Split the data. So what we're going to be doing is splitting the data set right now. So this hotel bookings raw, we're going to use this filter by time, and we're going to split it with the start date between the pre-intervention. So basically, January through March is the pre-intervention dates. Okay. So we're going to first create the pre-intervention, and then we're going to do the same thing then, and we're going to get the post-intervention. So let's take a look at these. So pre-intervention now has 4,000 by 8 columns, and that pre-intervention, we're still going to see that there's a treatment and control. And the way that we're able to do that is because of this cool geocoding thing, because we know that geo, anybody from that geography, is quote unquote in the treatment group. And even though that there's no experiment being applied to them, they will eventually have an experiment. And that and this pre-intervention data is actually pretty important. We'll see why once we get into the second stage. And then the experiment time frame, take a look at that. And what we can see here is now the experiment is actually going on. So anybody in this treatment that's been assigned to the treatment group is going to have some costs associated with the Google ad. So they're spending some money. Our hotel is spending money on marketing, and we're trying to measure if there is a bump, okay? Bump in bookings. Okay, so the first thing we want to do is I want to first check out and just make sure that our A/B test is set up properly. So I'm going to do a few things to check the balance. You normally want a 50-50 split. It's not the end of the world if you don't have a 50-50 split. There's things we can do. And you also want to have a decent sample size, at least above 30 data points. Now, because we are analyzing multiple different geographies, we're going to have a lot more than that. So let's check it out. Pre-intervention only, we can see that there's 2,074 and 2,075, 2,074 in the control and treatment. That's good. That means it's split evenly. And there's 1,391 observations, 1,393 observations. It can be a little challenging with Geo-Experiments to be able to get that even split. But we're going to see there's another package called Facebook GeoLift that actually helps you design the experiment and tells you which geo groups to set to control and to test. It's really slick. And then so we got an even split. That's good. Check the sales distribution. Is it balanced? So the next thing what I want to do is I'm going to take my pre-intervention only, and I'm going to group by this column assignment. And I'm just going to summarize the bookings, okay? So I can see here, it's pretty close, actually. The bookings for both the control and the treatment, and this is pre-intervention, so before the test, is around 1,100 or 1.2 million, and the treatment's around 1.2 million as well. So that's good. That means we have it nice and balanced, and that'll be good for us to help detect if there's a bump. And then if we look at the experiment only, control enter, we can see that the treatment though now has a much higher bump during that February to March period versus the control. So that's a good sign. And just with this limited information, we can already see that it looks like there's an effect that's happening. Okay. The next thing I want to do is I want to visualize the distribution. So here's how I would do that. I would use this geom density, and we can just take a look at the bookings. And what I see here, though, and this is a little bit of a concern that we may want to think about, is that there's certain geographies that it looks like are having much higher bookings on those days. Okay, and so there's a big skew here. One of the things that you might consider is doing a log transformation or something like that. We're just going to keep it basic though today. The booking summary, we take our experiment data, and if we take a look at just these three columns, assignment, bookings, and cost, all right? And then if I group on the assignment, I can apply these summary functions. So I can apply the mean by group, so to each of the different like treatment and control. And what I can do is I can calculate what the bookings are, what the bookings are when I do a log conversion, a transformation, and then we can also calculate the cost. So again, this is a good, just simple way, even not even doing an A/B test or anything special yet, to analyze. So I can see that on each. So this is by, remember, each of these observations are measured on the geographic level. So I'm seeing that during the control of the experiment, they're on average buying around 718, we'll say spending $718 per geography per day. Okay. And then the treatment, I see it's 814. Okay. So that's another thing. The average daily spend is around 814. That does, again, indicate that maybe the ads are working. If we do a log conversion, we're going to do that. And I'm going to show you, because I'm going to do this log transformation so you can see what the distribution is. And then also we can see that there's a cost. So we're spending about $35.90 per day to achieve the 814 versus $0 per day to achieve the $718. Okay. All right. So that's what all that means. And then what I'm going to do now is just visualize, and I'm actually going to do that log transformation. So this is basically the same plot that we had before, but what I want to do is I want to see if there's a difference in the means between these two, between these two distributions. So I did a log transformations, and I can see that this one looks like it's about 5.9 for the mean, and then this one's about 5.99. So is that different? Well, we don't know yet, and that's what we're going to move on to A/B testing, which is to test out to see if there's actually a difference between these two distributions. So what we're going to do is compare two continuous groups. So if you remember that kind of like weird diagram that I showed previously, if you follow that path down, what we're going to do is we're going to use a two-sided t-test to compute the difference in mean. Now, how many of you guys have ever used a two-sided t-test before? Put a 1 in the chat. Okay. So the equation actually, it's very simple. So basically you're going to compute this thing called a t-statistic for both, and then you're basically going to subtract the two to see if there's a difference. And what that is that difference in means is called the average treatment effect, meaning between the one and the other, between your control and your treatment, you're just measuring the difference between the two populations to see if there is a treatment effect. So we can do that pretty easily. We just take our experiment only. So we've applied the intervention now just to this data set. If we just take the assignment and the bookings, which is going to identify which each observation, which one was assigned to the treatment and the control. And then what we can do is we can calculate what's called the difference in means, or I'm going to store this as the difference in means data. But what we're actually going to do is we're going to compute this thing called a t-statistic, make sure it's two-sided. And we're going to compute bookings versus the assignment. All right. And the order is going to be treatment and control. So that's treatment first, control second. All right. So when we run this, you can see here, we get this output here, which has both the estimated t-statistic, the estimate, which is the actual average treatment effect. And then it also has the lower and upper bounds. And I believe this is at a 95% confidence interval, meaning that at a 95% level, there is a slight chance that there's going to be a difference in means, or that there is no difference in means. So that's what this means. We can also see that there's a p-value. And this measures basically the probability that the null hypothesis, I want to make sure I get this right, but basically it's the probability that we can reject the null hypothesis, which is that there is no difference in means. I think that's how it goes. I always forget it. I'm not a stats guy. I gotta be honest. I'm more of a data science slash mechanical engineering background. So this stuff, it's been a while since I've reviewed, what p-values were. But the main thing here is that we're seeing that it looks like there is an average treatment effect of that 96.2, which gives me a good indicator that there is an effect going on here, and that the confidence intervals are pretty, even though they're pretty wide, goes down to -1.87, but it also goes up to 194. So that means that the probability at a 95% level is pretty good that we're going to be, that there is going to be a difference in means. Now, I don't know how many of you knew this. I actually did not realize this until I started doing a bunch of research, but when you're doing a two-sample t-test, it has a very strong relationship to a linear regression. So if you regress bookings on assignment, just like what we did up here, and we give it our data using the LM function, which comes in R, it's part of the stats toolkit or package, and we run a regression. It turns out that if I do a summary on this, and if I take a look at this assignment treatment, I can see here that again, the estimate is 96.2, and the probability is the same, 0.54. And if I think we can get the confidence, can't remember if the confidence comes with that. It doesn't. Oh, and you got the p-value right here. So basically, when you do a linear regression, we're actually doing a t-test. And that's going to be a very powerful concept, because as we move to more complicated problems where we have what are called confounders, and this is what you're going to be dealing with on a more day-to-day basis. When you start to come up with these experiments, you're going to have very, much more tougher problems than just, spending, deciding how to do ad spend. So we're actually going to talk about one of those when we get into another problem called hotel cancellations. But anyways, so linear regression has a very tight relationship, and we're going to find out that we can actually use linear regression and logistic regression as well to be able to compute these average treatment effects, especially once we get once we add more variables into this equation down the road. Okay, and we're going to be doing that again in part 3. So the average treatment effect is going to be, and it's abbreviated ATE, and that is the 96.22. And we can get the difference in means data by running this. So this is the number of observations, so 1,393. So if we do 1,393 times the average increase in bookings, so $96 per day per geography, we can see here that it's about $133,000 in the bookings increase. Okay, so we've now answered that question. On average, it's going to result during that time frame of about a $133,000 increase. And our ROAS, which is our return on ad spend, which factors in costs, is just going to be the number of time periods. So the bookings increase, the number of time periods times the average treatment effect divided by the cost, which is $50,000. Okay, so that ROAS, the return on ad spend, is 2.67 is what we're estimating from the A/B test. Now, if you like this online experiments, what you should definitely check out are the next things that I'm going to show you, which is Google Causal Impact and Facebook GeoLift. Okay. And then next steps, A/B testing is great when you can make a controlled experiment, but what about when you don't have a control? So we're also going to be focusing on that here. How do we develop experiments? How do we analyze associations and get ourselves at least a little bit of information so we can make better decisions immediately while also waiting to develop good experiments. So we're going to talk about that in part 3. Before I do that, though, I do want to show you, and I'm not going to spend a whole lot of time on this because we're already 35 minutes into this, and I want to, really help keep this on track. But I do want to show you guys Causal Impact. So this is a little bit of a teaser of the bonus that comes in Learning Labs Pro. My Pro students are getting this. That's this file right here, this bonus Causal Impact hotel bookings. So what is Causal Impact? Well, it's when we actually take this time. Remember, it's a time series that we were actually analyzing. And what we want to do is we want to analyze it based on the lift that it gives us. It's this concept called uplift. So lift is basically the cumulated effect of how much more money we're generating from an online advertising push. Okay. So we can use 2 packages. There's Causal Impact and GeoLift. This one's made by Google, Causal Impact. It's an older package. It's not really designed for Geo-Experiments, which is kind of a newer thing. And then there's GeoLift, which is newer. It's developed by Facebook. And the installation instructions are up here. So yeah, it's actually not on CRAN, so you have to follow these instructions. So I'm going to just roll through this real quick. I'm not going to do a whole lot of explanation of some of this code. But what I did here is aggregated the bookings over time. So I got my control. It's the same data set that we used in part 1. And then what I'm going to do is I'm just going to do a quick visualization. So this gives you a time series view of what we just did. So that A/B test region was right in here. This is what we call the treatment region. This is the control, though. So nothing was applied to the control. And this is the sales that are aggregated at a daily level. So it's now no longer aggregated by geography. And we can see here that in the treatment, there is indeed that little bump here. So it's just another way to look at it. And you can see that slight bump. But we really can't tell if that effect was actually, is indeed, amounting to a return on ad spend just from this chart. So first thing we can do, we can use Google Causal Impact. What I'm going to do here is just run through the code to show you to do that. And what it does is it makes this plot, treatment models not found. Why not? Cannot find function causal impact. Oh, that's because I need to run these. Silly Matt. Make sure you load the libraries that you're going to use. That might help. Okay, so where was I? Back to the treatment. So we're going to analyze the treatment first. And this is the cool thing that Google's Causal Impact does. Now, one of the downsides, again, it's not at a geolocation because I had to aggregate everything to at the treatment level. So it's a little bit, I'll say, not as accurate as GeoLift, but you can see that there's a cumulative, there's an effect that it's found because this region seems like it's going higher than this region here. So it looks like there is a cumulative effect. Now, what we also have to analyze is the control. So we have to run the same code basically one more time. And when we plot the control, we see there's also an effect. And that makes sense because back here, we can see that this, even for the control, is going up. So, there's some sort of seasonality effect that's going on as well. So you can't just say like, oh, this is higher than this period, then we must be making lots of money. That's not the way it works. So what we need to do is we actually need to then, if we want to calculate a return on investment, we have to do a little bit more kind of work, manual labor, so to speak. So we actually have to analyze the two summaries that come from these models to analyze the relative impact. And that's what I'm doing here. So I'm calculating what's called a net effect. And this is the net daily effect. And then we're going to multiply that by the treatment prediction to get the bookings increase. And this one, I think, is the daily increase, and this is the cumulative right here. And then we can calculate the ROAS, which is comparing basically, let's see, because up here, what we're doing, sorry, I forgot to mention this. We have to basically subtract out the increase from the control model and the treatment. So we have to compare those two. And then that's how we calculated this ROAS estimate of 3x return on ad spend. And then the bookings increase, it looks like it's measuring around $153,000. Now, how does that compare with Facebook's GeoLift? Well, let's find out. So GeoLift is really cool. It can do even more granular analysis than Causal Impact. So when you do these GeoLift, you're going to first work with the pretest data, and you're going to do this geo read, which just formats it in the right way. And then you can do this geo plot. And this thing's pretty slick. So this thing will actually like show you all of the different regions and what it looks like. It's a lot of data to plot. It's going to be a lot of over plotting, but it tells you like which regions have the most and so on. And then what it does is it has this pretest market analysis. So this is before we come up with an experiment. So when we're trying to decide like how many samples to use or which geographies to like split our money up to, it has this GeoLift market selection tool, which is really slick. So you just give it your data, you give it the time periods that you want to analyze. So we might do a 7-day test or a 14 or a 28-day test, and then you give it your budget of 50,000. And it'll run through. Now, this does take a little bit of time because there's a lot of computations it has to go through. So I'm going to skip it just for the sake of time. And I'm going to skip right to the results. So then what we'll do is once we analyze it, we'll come up with that test and we'll select which markets we want to apply. Well, I already know which markets I want to apply. So I'm just going to pull in those markets from my treatments. So these are the markets that are in our treatment. And I'm going to store that as test locations. And then what we're going to do is get the test geography. Now, here's the key. It does have to be all the way from the beginning. So it has to be from the pre-intervention, the first date, which is Control Enter. That's 2015-01-05. Okay. And then it goes all the way to the end of the test. It doesn't take post-test data. So all the way to 315. Okay. So we got that. And the only thing that you have to add in then is you have to tell it when the number of the timestamp when your treatment begins. So treatment starts at 43. It ends at timestamp 70. We just run this GeoLift. And now it's running, and it'll give me this output for the geo test. For if you want to use it in Python, I just saw Fraser had a good question on that. You can use, yeah, so somebody else put RPy too. That's what I've done in the past. If you want to use this type of stuff in Python, GeoLift actually I think is only available in R. So you know, you'll find that from time to time, like a lot of marketing applications are only available in R for some reason. So it looks like it's done running, and the cool thing is it gives us a 15% relative lift, $144,000 incremental, which is the cumulative, and then it's got these cool plotting tools, so you can actually plot the lift. So this is the lift that we're getting. So it expected to have this during the treatment period. This is what the control kind of would have looked like. And what was expected, and then this is the treatment. So it actually does get that uptrend, which is cool. And then you can do the average, the ATT, the average effect on treatment, which is basically like your cumulative. So you just add all of these points up, and that's what gives you this, what was it, $144,000 increase. So conclusions. You know, this strategy is going to be obviously, I think this is an intermediate analysis, because it kind of, you know, if I was a beginner data scientist, I would probably be doing this, but if I was, you know, have a couple of months in and I'm starting to do some more advanced stuff, this is the thing that's going to get you probably more accurate results. And it's also going to help you leverage like the market selection and have a little bit better strategy when it comes to setting up these tests. So conclusions, I'm more confident now that all three tests have shown that there is a positive increase and an ROI. So think about it, $50,000 is what we're spending, and we're getting $144,000 return from GeoLift, 134 on the low end. So that's pretty good. And then also the other thing too, I want you guys to take away is using pre-test data is actually really important. All right, moving right along. We're going to switch things up now, and we're now going to be given a tougher problem. All right, and this is a more advanced analysis, but I really want to show you guys, because one of the things when I was talking to my social media presence, my followers, and developing this, is one of the things they told me is that, you know, nobody really covers how to set up experiments, right? So that's what I'm going to show you today. And if you remember, let me go back to the slides real quick. If you remember this, this causal inference, the 3-layer hierarchy. So we were just doing, whether we realize it or not, interventions. Okay, so we're actually doing the intervening, and we're actually determining and making causal inferences because of what we're seeing. But what happens is normally before we do that, we have to do some sort of association analysis before we can just like come up with a test. Now, for certain types of tests like Adspend, it's very simple, because, you know, ads should, you know, give us more eyeballs, which hopefully will give us a return on our ad spend. So that's a very straightforward question. But we're going to see that what happens when we get like these bigger data sets and we have more complex problems where we have lots of features now that could be, you know, influencing an outcome that is either positive or negative for our company. So that's what we're going to focus on now, is moving into this third part of the presentation, which is a little more advanced, but it's actually going to be more closely related, in my opinion, to what you're actually going to be doing as a data scientist. Okay. So the goals here is to show how correlation and association can help the business before we do any sort of experiments. It's going to help us come up with the experiments, and it's also going to give us insights to our data that are actionable. All right. We're going to use modeling to understand the system and draw conclusions and develop experiments. That's our goal here today. We're going to work with multiple confounders to develop a complex business model. So it's not just going to be like a simple A/B test, you know, one input, one output. There's going to be multiple inputs, and we're going to have to understand the business, the complexity of the business model. We're also going to use Bootstrap to gain confidence intervals on the estimated pre-treatment effects of one of the things that we're going to see, one of the insights we're going to get from this. And important also is to explain what is not the goal of this. So we are not actually going to be applying any sort of treatment in this part of the presentation. This is before we come up with an experiment. Hopefully that makes sense. This is instead how we develop good experiments, and which can then be modeled for causal effects once we come up with an experiment. Does that make sense? Let me know if that does not make sense. Hopefully that makes sense to everybody. The key questions that the business has is what causes cancellations and what can the business do to decrease cancellations? Okay, so that's a big problem for hotels. You know, that's something that you're going to see how, like, literally how much cost is associated with cancellations. Important note, this is a scenario that is pre-treatment. I've already said that, but I'll say it again. And hotel cancellations is significantly more complicated business problem than the hotel bookings problem. That's why this is advanced. So we need to build up to experimentation, and we need to design the experiment. That's going to be our ultimate goal coming out of this. All right. So first thing I'm going to do, I'm going to load in some libraries: Tidymodels, Tidyverse, Data Explorer, Correlation Funnel. Those are all packages. I'll explain, you know, what they do when we get to certain sections of this. First, the next thing that we're going to do is we're going to import the data set. This is our cancellations data. This is what it looks like. It's a typical type of machine learning problem where you've got is canceled, and you want to figure out what is related to, cancellations. So each one of these, so we've got 32 columns and 119,000 rows, and each one of these is a customer. All right, and that customer has made a booking, has booked their hotel, and has either shown up or has canceled. Okay. And what we want to do is we want to figure out, how to reduce the cancellations. Okay. So, first question I have is just a general business question. How many people actually cancel? Is this like even a problem I should be thinking about? So that's what I'm doing here. What I'm doing is I'm taking my hotel cancellations raw, just selecting this is canceled column. Okay. And it's going to be zeros and ones. One means that person canceled. Zero means that person did not cancel. Okay. And then what I'm just going to do is analyze the proportions. So I can see here that the number of cancellations is huge. Think about this. During this time frame that we're analyzing here, 44,000 people canceled. That's over a third. That's 37% of people that book a hotel have canceled that hotel. I was kind of shocked when I saw that. And this is real data that has been made publicly available from a hotel. So, so what's the cost of that? So I just did some kind of back of the napkin calculations. We got 44,000 people that are canceling, and figure at $200 up on average, maybe nightly room is say 250, 150 bucks, whatever. So 200 for an average stay times or 200 for an average room times 3.4 days. So I actually calculated what the average stay is, and it turns out it's 3.4 days is what people stay on average, and that amounts to $30 million. So that's the cost of people canceling. And if they don't show up, or if they cancel in advance, doesn't matter, but that's what it's costing that hotel potentially. So if we can reduce that, say 10%, that's a $3 million savings. I'd be happy with that, saving $3 million. So this is actually a big problem. This is something that we should definitely analyze. Now, I'm going a little bit late on time. So what I'm going to do is I'm going to speed through some of the data pre-processing steps. This is all stuff that you need to know how to do if you're going to become a data scientist. Basic feature engineering. We're going to calculate things like total stay, total guess, whether or not a different room was assigned to that person, which could irritate them. And we're going to remove some of the features we don't need. So that's what we're doing here. It's now 28 columns by 119,000. We're going to fix some of the missing data. So that's what I'm doing here. I'm using Data Explorer to see which columns have a lot of missing data, removing them if they have too much, if they have too much missing data, and then imputing if they don't, and then removing the date features that I don't need. Okay, so this is I went from having raw data to now it's I'll say semi cleaned up, and it's at least workable. And now what we want to do is get into some of the insights. All right, so we need to do association analysis first. This is the first step before we get into like, coming up with an experiment. Do this first. All right. So I'm going to use this package that I developed. It's called Correlation Funnel. How many of you guys have ever used Correlation Funnel? Put a 1 in the chat if you've used Correlation Funnel before. Okay. All right. So we do have some people who have actually used it. This is like, I could shout this thing off the rooftop. You probably wouldn't, you probably still won't download it. This is the best package for analyzing associations that, like, it's insane. I don't know why more people don't use this technique, but it is what it is. So what we're going to do is we're going to take our hotel cancellation. I'm going to run this function called binarize. All right. It'll take a second to run because what it's doing is it's going through for all 119,000 rows and 21 columns. It's taking each of these columns and turning them into a binary field. So for things like that are numeric, like lead time, it's going to bin those into, is it lead time 0 to 18 or 18 to 60? It's going to put those into bins. And then for character fields or categorical, it's going to dummy encode them. So we're going to have a bunch of binary features, zeros and ones. All right. So this is what the data set looks like after I binarize it. All right. And now you can see there's a lot more features in here, but this is good because, we have 81 columns by 119,000 rows. And what we can do is we can analyze the correlations now between the binary features. All right. So that's what we're going to do next here. We're going to run correlate, and we're going to correlate it. And this is very important. You need to pick the right feature in this binary, but we want to correlate it against is canceled 1. That means somebody canceled. We want to find out which features correlate against it. So if I just run these 2 lines here, what it's going to do is it's going to run correlations on all of those. And we can see that there's a perfect correlation or a perfect inverse correlation between is canceled 0 and is canceled 1. But what really helps us is when we plot this and we can visualize it and we can start to make assessments based on the information that we're seeing. So this is why it's actually called correlation funnel. It's because it actually looks like a funnel when you put the most highly correlated features towards the top. So we can actually see quite a bit of good information that we can start to develop some assumptions off of. So the first thing is that is canceled 1 is super highly correlated with reservation status canceled. Now, this is actually a problem because this is what we call it's basically a misleading variable because it's tracking the is canceled so closely because obviously, if the reservation status, if they cancel it, then their is canceled is going to be a 1. So we got to remove this variable. So that tells me, something immediately, like we got to get rid of this feature here, kick that one to the curb. The next one though is very odd. This is super odd. And I don't know why this is, but like the deposit type, if it's a non-refundable deposit, which means that they actually don't get a refund if they canceled, more people who are taking non-refundable deposits are actually canceling. And I don't get that. But this is the data that like literally, it's real data. And, I don't know what it is. Why anybody would cancel if they've already paid for it and they aren't going to get their money back. Maybe they do fight for their money back and they do end up getting, part of it back or something. I don't know. Next one's very interesting. Country, Portugal. So people that are coming from other countries than Portugal are not canceling nearly as much. So there must be something going on with Portugal that is causing them to cancel more frequently. Then also previous cancellations, if they've canceled before, they're more likely to cancel their reservation, which makes sense if they, if you track their history. Lead time. So if lead time is 160 days out or longer when they book, they're much more likely to cancel. So that makes sense because like if I'm booking something 2 years in advance, heck, I don't know where I'm going to be, in like a month, let alone 2 years, right? So these are some of the inferences that we can start to make. Now, is this enough to apply causation, saying like, oh yeah, because they're 160 days out, then that's causing them to cancel? that's where this whole causal inference and experiments and things comes into play. And we'll talk more about that one, but that's how I read this. So the next thing we need to do, what I'm going to do is I'm going to do a little bit more feature engineering, and what we need to do is we need to shrink this data set down, because if we have too many features in this causal analysis, you're just going to get a bunch of crap that doesn't mean anything. So like some of these features down here, I can see it like total guess doesn't really have any effect on is canceled. So we need to drop that one. We need to drop some of these low correlations, and we really want to focus on the structural properties of this business problem. Okay. So that's what I'm doing here. I'm going to shrink the data set down and just select certain features. And then I am going to, because I see this is so clearly heavily weighted towards Portugal, I'm going to make country Portugal and country other, and actually drop country altogether and just keep the Portugal feature in here. So that's what I'm doing here. Got the subset. Let's next move on to the third piece. So a lot of people who do causal inference, they come up with this map that is called like a causal graph, or a DAG, DAG, directed acyclic graph. So I don't really follow that nearly as much as what they say out there, because it seems like they kind of pull them sometimes from their butt. But what I will say is, if you follow the associations, that gives you the graph, or at least it gives you the features that should be on the graph, which I think is pretty important. So the first thing I'm going to do now is, now that I've subsetted my data, right? I've created this subset of features. It looks like this. It only has 15 columns now. So we had like 44 columns. We're now at 15. I'm again going to run binarization on them, and we only need to do this once. But then what we're going to do is repetitively look at different features and see what correlations are with those features. Okay. So when I binarize it, this is what it looks like now. We have 47 columns, but that's shrunk down from like the 88 columns that produce this plot. And what we're again going to do is we're going to start with is canceled. And this is my process. So the first thing I'm going to do, here, hold on one second. We're right here on 125. We're going to again do the same visualization. So what I'm doing here now is I'm picking the top features, and I want to know, okay, now that we know what's correlated with is canceled, what's correlated with deposit type? Okay. And just a side note, I actually did this same type of process once when I had a consulting job with a company called MRM McCann, and we were analyzing the website data, and they do marketing for General Motors, and we actually use the same style of technique to help determine and significantly increase vehicle purchases, because we found out that one of the web pages was highly correlated, and it actually happened to be the web page that's related to the test drive of the vehicle. So once we figured that out, the goal wasn't to get them to buy the vehicle. The goal was to get them to test drive the vehicle. And we're going to do kind of like that same type of journey analysis here to help us kind of understand the system. All right. So next thing, what we're going to do is we're going to analyze the top features. So we're going to take we want to analyze that deposit refund type and make sure it's non-refund. And we want to see now what is highly correlated with that. And we want to drop is canceled. So we don't really care about is canceled anymore, because what we're really focusing on is the top most correlated feature to is canceled. So what causes refunds, or what is most highly related to refunds? Well, we can see here market segment groups is super highly correlated, like almost 0.5. So if this is a group, meaning it's part of a travel group, right? They're purchasing, or they're making non-refunds. And also we see that groups and country Portugal. So this is interesting now, because maybe there are more groups that are coming from Portugal, and when they try to travel to this hotel, they end up canceling. And that could be something that's very interesting, versus other countries. All other countries, when we aggregate those, they're almost like they're hardly ever doing the they're more likely to do no deposit down. Okay. So all right. So is canceled, non-refundable. We see here that market segment is groups, and country Portugal now is pretty important. And that's kind of like starting to shape this. So we can create an association map here, and we can start to like track, which features and, market segment groups is somehow related to deposit non-refundable. And we just start taking some notes, and that's what I'm doing here. We just keep doing that. So next thing, what we're going to do is take another feature. And because I see that market segment, what I want to look for is features that were highly correlated, but are not as highly correlated with non-refund. So I saw lead time 160 to infinite. Okay, so I looked at that one next, and I see here that there's not a whole lot of correlation between, I mean, there is some correlation between deposit type, but it's not nearly like the 0.5 that we saw. So now we're starting to see and fill out this. One more feature just for the sake of completion. I took a look at the total number of special requests. When that is 0, those special requests, they tend to cancel more frequently. But if they have made a special request, it does in fact look like they are keeping their hotel booking. Okay, so now at this point, we know a lot more about this setup, but the key thing is, we're now ready to start doing some causal hypothesis. This is not, saying that there's causation, but it's saying, what can we do, or what theories do we have about what's causing this that we can actually affect? Now, I have 2 different questions that I developed based off the information I saw, and you might have more questions that you develop. But I want to show you the difference between these 2 questions. One is a good one. One of these is a good question. One of these is a bad question. So the first one is question: do groups tend to cancel more? Is that a good or a bad question? What do you guys think? Good or bad? Okay. Simon's got it right. It is indeed a bad question. Why is that a bad question? Well, it turns out that we can't really we can't really create an experiment around whether or not groups are canceling. Like, we could say, hey, we just won't allow groups to ever, come to our hotel. Well, then you're, probably losing out on a significant source of income. So that experiment would be a very bad experiment to run. I would never run that experiment. But the second question is something, and the reason that first question is bad is because it's really out of our control. We can't really control it, okay? But question number 2 is, will reducing lead time reduce cancellations? Okay, this is good, because even though they select when they want to book, we can do things to influence when they book. Meaning, we can offer discounts if they, via email, or when they sign up. Show them the rates that are much lower here in the next 60 days versus, something that's way far out there. And if they see that, they might opt to book sooner rather than later. Okay, so we can actually influence that, and that's why question 2 is the one we want to follow through. So our hypothesis is, our first question is, will reducing lead time reduce cancellations? That's something that we want to move on and actually model. So we're going to try and do some basic machine learning and modeling to understand, what effect that could have before we just decide to create an experiment. Because if it has a low effect, then we don't want to do it. And it's because experiments, they cost money, they cost time, and it's really important to get these experiments right and set up properly on really good information, if you're going to be spending a lot of time and money trying to analyze this stuff. Does that make sense? Hopefully that makes sense. All right. So what we're going to do is first create a simple logistic model, or a logistic regression. So what I'm doing here is I'm actually going to just analyze 2 features. Okay. So the first feature is canceled. And then what I did was I bucketed lead time into those segments. So like this, for example, is 160 days to 737 days. So it's pretty, that's the farthest group. This group is, they're only 18 days, so less than 3 weeks out. So what I'm going to do then is I'm going to use Tidymodels to create a logistic fit lead time model. And then what I can see here is I can actually extract that model that I created, and we can look at the terms that are in that model. And I can see here that this first estimate here is 1.98. Now that it produces what's called the log odds. Okay, so this is the log odds, but what we want to do is we want to convert that to odds. So when I do exponential 1.98 for the 160 days out, what that means is that there's a 7.2x risk for if they are more than 162 days out. Now, I'm going to caution you, this is not the final solution because we have a lot more features that we actually need to account for. But just this, if we're trying that simple A-B style on this, all else equal, which we know it's not because there's a lot of other influential factors in here that are influencing whether or not they're canceling, like whether or not they're part of groups, whether or not they're coming from Portugal. So that's but you know, if I just do this risk analysis, basically what I see here is that if we can reduce their lead time into this bucket, it looks like we can drop them from a 1.98. Remember, that's log odds. So 7.24 risk, factor risk to a 3.25 factor risk. So that's literally cutting their risk by 55%. All right. Now, problem, again, this isn't reality. Lead time is not the only thing affecting cancellations. So we have to consider what are called confounders. And that just means that we don't know the full story yet. And what we need to do is we need to approximate it with a more accurate model. So consider if I actually with this model, if I did like a training and testing set, this model would really suck, right? Because I only have one feature in there. But if I expand it to the whole 15 features, then we'll have a little bit better idea of the full story. And that's where machine learning comes into play. So the problem though, and one thing I will say, and this is going to lead up to the next lesson that I do on causal inference, is that you're really kind of confined to logistic regression unless you start to do transformations, which are a little bit more complicated, and you have to shift from average treatment effect to conditional average treatment effect. That is something that is going to be outside of the scope of this lesson here, but I do plan on tackling it later. So we're going to use what's called a penalized logistic regression model. That's elastic net, but we're going to use it for logistic regression. So what this does, the advantages here is that it's more robust to bad confounders, meaning confounders that we've included in our model that just don't, that cause our normal logistic model to go all crazy and overfit. So it's going to like kick those ones out. And then what it does is it actually gives us coefficients. So this is the problem with like black box models like XGBoost, Random Forest. They don't actually give us coefficients. So those coefficients are our average treatment effect. Remember, those are the log odds. That's the, what we really want to analyze. So how do we do that? Well, what we're going to do is we're going to take that hotel cancellation subset and we're going to create a training and testing split because we have to come up with a good model first. If our model sucks, then, our any inferences that we draw off or conclusions that we draw off and come up with our experiment from are probably going to suck too. So, and that's just going to cost us a lot of time and money, and our company's not going to be really happy when we say, oh, we don't have really anything, nothing much came out of this experiment. I just spent hundreds of thousands of dollars on that. You're fired. Okay, so we want to avoid that. So we're going to create a recipe, and this is going to allow us to, again, kind of prepare it for machine learning. One of the things I did do is I discretized the lead time. So you can see that the first bin, so you're going to see these bins up here, bin 2, bin 3, bin 4. Now this is what we call dummy encoded. And that means, it just means that bin 1 is part of the intercept, okay? If we did one hot encoding, we'd see bin 1 in here, but then, we'd have more features that we have to, kick out basically for our logistic regression. We don't want to do that. So bin 2 is going to be 18 to 69. Bin 3 will be 69 to 161 days out. And the last bin 4 will be 161 to infinity. Okay. So next thing, what we're going to do is we're going to model using our logistic regression model. I am going to give it a little bit of a penalty. So basically what that's going to do is we got a lot of confounders in here, a lot of predictors. So it's going to kick out the ones that don't really matter that much. So it's going to do that automatically. And then we're going to fit the model. This model does take a little bit of time to fit because if you see it, it's 95,000 rows by 28 columns. So it will take a second to run. And then what we're going to do is we're going to get the performance first. So we want to see is our model good? That's the first question we need to ask. So we're going to see we got a 0.885 AUC. That stands for area under the curve. That's actually really good. That means our model is not crap, which means that any inferences that I make from this model, including actually looking at the expected log odds for the lead time, is going to be probably pretty close to reality. Okay. So the next thing we can do, we can then take a look at our GLM fit, and we can start to extract out those terms. Remember the terms from before when I did that linear regression. Remember when I did that linear regression over here, where we said, oh my gosh, this is crazy. It actually provides that, the estimate is the same as the t-value. Well, that's the same thing that happens with logistic regression, except it's the log odds. So instead of an average treatment effect, what it is it's the treatment risk, basically. So if I take a look at my GLM net terms from that model, and if I arrange them descending, I can see lead time bin 4 has a 1.12 estimate now. So and I can see here though that if they're in bin 4, but if they shift to bin 2, their risk goes from a log odd of 1.12 down to a log odd of 0.64. So what does that mean? Well, if you do exponent 1.12, you can see that's a 3x risk of canceling. And then they've just now shifted to a risk of 1.89. So if we calculate what's the difference there, that's roughly a 36% reduction in risk. And remember, we've got a $30 million problem. So say like everybody that we develop this experiment for, say everybody takes the experiment and, we send them an email and say, hey, we'll give you 10% off if you pull in the dates of your vacation from, 30 days out, or from 300 days out to, 60 days out. Obviously that's not going to happen. But if everyone did that, this is what we would save the company. $10 million. Now, remember, we don't need everyone to do it. We just need some of them to do it. So if 25% of them do that, we would save the company on average $2.7 million. That's still pretty good. I mean, heck, I'm probably getting a pretty hefty bonus at the end of the year if I saved them 2.7 million. Now, the next thing is though, it's really important to understand that we don't have, we need to capture what is the probability that we're going to succeed with this. So that's the other thing. And we don't really have that here. All we see is penalty. We don't have like a confidence interval. So we want to create a confidence interval. Unfortunately, this is a very long running script, but what you can do is do what's called the bootstrapping. How many of you guys know what bootstrapping? What have you ever done bootstrapping before? Put a 1 in. Okay. So a few of you have done some bootstrapping before, and that's what we do here is we generate bootstraps. And then what I would do, and this, I'm not going to run it right now, but this takes, even for 25 times, this takes probably, 30 minutes to run. So bootstrapping just takes forever. What I've already done though, I ran it 10 times and I stored those as boot results. That's over here in the bootstrap results. I'm pulling that in. And we can analyze those results if we filter our bootstrap results, which looks like this. Remember, we got a lot of terms in here and we're calculating the estimates for a bunch of different, basically like 96,000 rows that are sampled with replacement, okay? And that allows us to, if we focus in on just the lead time, bin 4, we can see that the log odds are somewhere between, and if I do this, I run this boot CI, that's what we get here. We get the log odds, the range of the log odds for all of the different features. And if I arrange descending lower, we see here it's between 1.07 and 1.17. Okay. So that's what it looks like. Does that make sense? Yes. So 1.12 was the mean estimate, but we can see it's exponential 1.07, and exponential. So roughly 2x risk versus and all the way up to 3.2x risk. So somewhere in that range is what the risk is if they're in that bucket. Okay. All right. So there you have it. We covered a lot of good information here. We covered basically how we can design an experiment now, because we have information from our data that supports that, hey, we should tackle this lead time and we should come up with an offer on that. So here, I want to leave you guys with some stuff, these are the 4 steps to create an experiment from this. And I'm actually going to do this in another workshop. We're going to create a randomized controlled experiment, kind of similar to A/B testing, but much, much more complex because we have confounders now, right? And we have to control for those confounders. So what we would do is send emails off, maybe offering them, 20% off to book in the next 60 days or so. And then we would test our hypothesis. We would use this thing called Causal ML, which allows us to do uplift modeling and then report the impact on revenue. And that's basically how you show a savings to your company. All right. The next thing, we have not talked about causal machine learning yet. We've done a little bit of machine learning here, but it's more been for association. All right. And remember, the next step is we actually have to do the intervention and do some machine learning on that. So I just don't have time or data yet to cover that. So future workshop, and then some conclusions, guys, for you about the analysis that we saw here today. So I do have some, so I've given you a lot of good information here today, right? I've given you some tools to perform causal inference. We saw some beginner tutorial. We saw even an intermediate tutorial and an advanced tutorial, which you can leave here today and actually apply to your current or future company. That's pretty sweet, right? But the question is that going to make you $150,000 or more? Because remember, that's the bar that I wanted to hit today with you. Answer to that is no. Okay. Why is that? Well, because you're probably going to freak out when you go to your first job or you go to your next job and you see that they have a big, SQL database that's set up and it looks like this, where you've got 1, 2, 3, 4, 5, 6, 7 tables, and you have to link them all up, and you have to, and you realize that, oh, you just pull in one table and it looks like this, where these are all the features and everything that are in it. And you figure out, holy crap, this is 30 million rows by 123 columns. And pretty quickly, you get to the point where you realize that real world data is tough. The simulations that, we go through as we start to learn data science, and it kind of sucks because, you start off with iris and MT cars, and, you think like, oh my gosh, I can do this stuff. And then you get to the real world and you're like, oh crap. So I'd like to help. And what will earn you $150,000 per year, and this is what companies will pay you for, surprisingly enough, is your data science process. And I learned this when I was working with the companies like MRM McCann and selling I could never sell my skills, but when I sold them, hey, this is the process that I'll take you through, they bought. So the problem is you probably don't have a data science process. So I'm going to give you mine right now. Remember at the beginning of the training, I said, get your notepad paper out, because this is the time to take notes. This is the stuff that you're going to leave with that is really going to help you in the future. So my data science process looks something like this. So step 1, data collection. Step 2, I then explore the data. And we saw a little bit of that here today, like, with some of the plotting and some of those things. The data cleaning, which I kind of glossed over just because I really wanted to focus on the purpose of the training, but that's actually the really important stuff, like fixing outliers, working with dates, working with, some of that stuff that I kind of glossed over. The data pre-processing, getting it ready for modeling, being able to do the cross-validation. We didn't even see cross-validation. We should have cross-validated today. Model selection, picking a good model that approximates, and then also doing what companies want, which is building web applications. And this is actually where organizations get value. It's when you build things like this, which is an application. You can build it with multiple different technologies out there. But the cool thing is that it actually takes the machine learning and automates it for them. It helps them with their business process. So imagine, you come up with your experiment and it works, and then you have to put that model into production. Giving people a tool like this to help them be able to make those decisions fast, lightning fast, is going to be pretty powerful for the company. And imagine what happens to your career when they see that you can do this. Problem is, though, most of you cannot do this. About maybe 2% of you can do this on the call. So I want to focus on the 98% of you that cannot do this yet. So if you cannot do this, put a 1 in the chat right now. Can you make those types of shiny apps? Put a 1 if you cannot. All right. Okay. Well, at the beginning of the presentation, I told you you're going to leave with everything to make 150K. You thought that was the analysis. It wasn't. So if you would like to dominate data science with R and be able to get yourself a 6-figure data science career doing stuff that I showed you like today and being able to handle the real world data that you're going to face, then I have a special offer for you guys. I prepared something. Would you like to see it? Put a 1 in chat if you guys want to see it. All right. I'm seeing some 1s. Okay. So pop quiz, guys. Question for you. Shortest path between 2 points. What's that? What does that look like? Let me know in chat. Anybody know what the shortest path between 2 points is? Straight line. Michelle wins. Okay, it is a line. Now, when most people do their data science career or journey or educational or whatever, they suffer from something that's called shiny object syndrome. And I was right there with you. Because of SOS, it actually took me 5 years to become confident in data science. Now, has anyone on this call caught themselves with SOS, where every time they go online, they see something and it doesn't, it takes them off of their path? Put a yes in chat. Put a thumbs up, yes in chat. Okay, Michelle, I see Norm, Anna, Tommy. Okay, all right. I was right there with you again. So no shame in that. It sucks, but that's kind of the path that I took. So tell me which path you think you're on right now. Path 1, which is straight, takes you right to a job, takes you right to a promotion, takes you right to where you want to go. Or path 2, where we're all wobbly like this. Yes, 2, 2, 2. Okay. Yep. This is the path I was on to. All right. Now I see everyone else doing the same thing, including myself, is, that path 2 just like totally dominates you, and it takes forever. It takes you from something that should take you a month to learn takes you like 6 months or 12 months. So to combat this, I've created something cleverly named the path. Now the path does 2 things. First, what it does is it shows you what to do for any data science project, and second, it shows you what skills to learn along that path. And it's the biggest secret to my success as a data scientist, a teacher, a coach, and a consultant. Now, before you can solve any problems, you need a foundation in data science. So the path starts with foundational skills. And those skills are things like data cleaning. It's all the basics like wrangling, visualization, exploratory data analysis, machine learning, clustering, reporting, programming. These are the things that you really need to do before you can start doing some of the more intermediate or advanced things that we saw today and that you will face in your career. But the second thing, and this is really important, and this is what companies actually want, is business problem solving skills. So the thing that I displayed today, which was how to do the correlation analysis, those types of things, or be able to come up with the way to develop the experiment. That's what companies want. So business problem solving skills that companies are looking for, correlation analysis, how to cost a problem. We displayed that today, how to pre-process data, how to tell the story and explain it to executives, how to do automations, automated machine learning, productivity enhancements, how to do explainable AI, actually explain what's going on, how to do sensitivity analysis, what happens when you change a key feature of that model. Those are the things that companies actually want. And that's really where, once you start to get the business skills, that's where companies start saying, yes, we want you to work for us, or yes, you're ready for a promotion. Then it's time series forecasting. This is kind of a niche thing that like every company faces though. If you work for a company, every single one's going to do some form of selling. And that means if you can predict sales, revenue drops, supply and demand, you're going to become very valuable. All right. You're going to be, if you're able to predict what companies are going to be, experiencing in the future, that's one of the most profitable skills that a data scientist can possess. But it's also very easy to screw it up. I know, I've been there. I have made forecasts that overfit and they went all erratic. And when companies order way too much, they aren't very happy. So we want to avoid that, and I've also spent 10 years in time series forecasting, so I did get a lot better. And then next is building tools for yourself. So you need to be able to create what are called repeatable business analyses. All right. And that's the key, is when you do something in a company, that's not really what the company wants. It's what they need is they need you to automate it or put it into what's called production. So that is the key piece where the business actually starts gaining value from what you've done. Okay. And it's the single most valuable way for a non-techie to get value from your work. All right. And then last, so once you can build tools for yourself that automate some smaller things, then what you do is you graduate and you start building tools for your company. Now, it's a little bit more challenging because, but this is really the most powerful thing because you're automating entire business processes now. So things that your company does every day, every week, that might be like manually done. You're now automating all that stuff and creating decision-making tools. And what it does is it actually shows the company that you can do more with less. And that's exactly what companies want right now. They don't want to have you depend on the IT department or all these resources to be able to support you. Companies don't have that luxury nowadays. So, and it also automatically turns you into a leader when you can make these types of applications yourself and deploy them. So recap, path, you have all the knowledge that you need to complete data science projects by yourself. You don't need the CEO to get angry and ask you to solve problems. You don't need data engineers. You don't need to be micromanaged by a project manager. And you don't need the IT department to do their jobs. So with the path, you transcend and you actually become what I call and what I've termed a business scientist. And that's somebody that can basically, it's a one-person wrecking crew that can go in there and deploy things and build the things that they need to do and get the insights and save the company a lot of money. And those people succeed, okay? So becoming the business scientist follows the path. And you do that with the first course that I'm offering today. So with that, you get Data Science for Business Part 1. Now, in Data Science for Business Part 1, this is where you learn the foundations of data science so you can perform basic machine learning, produce the high-quality business reports, clean and work with data, visualize data, which produce those insights. You can do the machine learning algorithm foundations, and all of the skills that are general foundational skills for all data scientists and data analysts are covered in this course. Inside of the course, you learn the 20 most important functions for data wrangling. You learn how to master ggplot2 and visualize data like a pro. You learn how to work with special data types. You learn how to create the functions and iterate using the per library, which we didn't actually run this, but as part of the Bootstrap function, that was the per library. You also learn how to do k-means clustering to do one of the most important things, which is clustering and actually showing associations between customers. You learn how to do machine learning to model product prices for your company. You learn how to make two different reports. One of them is shown here. This is the customer segmentation report. But really, what does this do for you? And that's what you should ask yourself with any course that you take is, what's it going to do for me? Well, this is David Stevens. He's one of my students, and he says, I nearly doubled my salary, and it's because I'm taking your courses. He sent this to me in an email. So what you're getting today, guys, is Data Science for Business Part 1, a $659 value. Now, next on the path is business problem solving. And again, this is the most important skill that companies want. So for that, we have Data Science for Business Part 2. In Data Science for Business Part 2, you solve a $5 million per year business problem. You use a repeatable framework that can be applied to almost any business problem. You solve the entire business problem step by step with me coding alongside you. You use advanced tools like automated machine learning and explainable AI, and you develop financial decision-making using what's called return on investment. And this is key because this is where the organizations, that's what they actually want. They want to see before they put your model into production, you need to show them that there's going to be an ROI and what the expected value is that they're going to return on that model. So to get there, what you learn in this course is my business problem solving framework. And these are the key steps. So I could, again, shout this off the top of the roof, learn the business science problem framework. This is how I did amazing things when I was consulting. These are the 7 steps that I take companies through every day. But still, data scientists, they hear that, goes in one ear, out the other. Yeah, man, I want to do machine learning. Okay, I get it. But you need a problem framework first. And this will tell you how to take that organization through that problem. Okay, it's super critical. It's actually gotten like 50 plus people jobs, which is crazy. And then also, you learn inside there the sexy stuff. H2O AutoML. This is one of my favorites. It's a super productivity enhancer, and I teach you how to learn how to make hundreds of models automatically, how to cost the problem to show leadership, and to help them determine whether or not that problem's even worth solving, because last thing you want to do is spend a whole lot of time, again, on a problem that's not worth solving. And most data science teams, shockers, skip that step. How to do pair plots. So this is key to giving quick insights. Using visualization tools like correlation funnel and pair plots. I mean, hands down, you're going to be running laps around your peers. Feature engineering. So when you're ready to then take that data and get it into a machine learning model, you have to have really good features. And I show you how to do that in this part of the course. You also learn the H2O leaderboard to make hundreds of models and track them. You learn how to do the model performance component, which is where you will actually select the best models to move those into the next step. You're also going to learn how to explain those models to your executives. This is really important because when you get into a conversation with an executive, they never trust your machine learning model. Like when you tell them like, hey, I've got this model, it does amazing. They don't care about that. What they care about is how, like, if you can take a person or a customer and actually say, okay, because that person is working a lot of overtime. They've worked at 4 companies before and their job level is a 1, meaning it's very low. They are a 74% probability of leaving the company, a high risk, versus somebody else who's not working any overtime, has stayed with us, for years and years and years, and has a high job level. So those insights, that's what gets them to trust your model. It's not the like AUC and ROC curves or any of that stuff. You also learn how to optimize the model, tune it for expected savings, how to do the sensitivity analysis component, which is, when they want to like tweak different knobs to your model, you can show them how to do that and walk them through it. And also you need to be able to give them a recommendation. So at the end of the day, they only care about what are you recommending to me, Matt? What should I do? What action steps can we take to get the outcome and, reduce those cancellations or, whatever. So that's what you learn how to do in this course. Again, and I'm not trying to be funny here, but like always ask, what is this going to do for you? Well, here's what it did for Augie. This is one of my students. He sent me this big in my Slack channel. He sent me this this nice testimonial here. He saved his company over $5 million per year by developing a vehicle triaging model for his company's claims department. He said the project was a huge success. I got a personal message from the CTO, and the CEO just mentioned the model in our most recent investor call. And the skills displayed during the project were a major consideration factor in my promotion to analytics manager a few months later. And it was all thanks to the skills picked up in this course. Pretty powerful. So today, guys, you're getting Data Science for Business Part 1, Part 2, total value, $1,718. Next on the path is time series. This is huge. For time series, you're getting my high performance time series course. And I've actually developed all of these packages for you, and I've designed them for this particular course so you can do what is called high performance forecasting. All right. So I am the developer on all of these packages. And in this course, you learn a special type of problem that costs organizations millions of dollars. You learn strategies from 4 state-of-the-art time series competitions. You use the custom software that I wrote to make forecasts at scale, and we're talking thousands. And you use advanced techniques like machine learning, deep learning, and feature engineering. Inside of this course, this one's jam-packed with time series if you're interested in becoming the expert for your company. And again, this course has literally gotten people jobs. So you learn the 6 most important time series visualizations, how to summarize by time, secret of the pros, how to do transformations. So things like box Cox, how to deal with outliers and do imputation. You learn how to work with external regressors, which is a secret, so powerful for increasing your forecast accuracy. You learn my model time workflow, which streamlines forecasting. Literally, things that used to take me 10,000 lines of code now only take you 200 with this workflow. You learn how to do ARIMA. This is the enemy. You learn how to use that. And why is it the enemy? Well, because we're going to beat the enemy. So ARIMA is our baseline, and XGBoost and some of the machine learning algorithms, we're going to beat the enemy. And I'm going to show you how to improve over them. then I'm going to show you how to, they're going to rekindle their friendship. And I'm going to show you a REMA boost and how to improve the enemy, taking the best of both worlds. You're also going to learn how to do hyperparameter tuning to stabilize your model performance, do ensembles, 5 bad models make 1 good one. You're going to learn deep learning. So deep AR is a fantastic forecasting tool, and you're going to compare it with a REMA. You're also going to use both deep learning and XGBoost to create an ensemble model, which is really nice. But what does this again do for you? Well, how many of you guys on the call have ever felt imposter syndrome? Put a 1 in the chat if you've ever experienced imposter syndrome before. Okay, so I was right there with you. And that's one of the reasons that it literally took me 5 years to feel confident. So I started learning data science in 2013. And by 2016, I was still very unconfident. So think about that. That's like 3-4 years of kind of back and forth. Certainly I got a little bit better, but I was still, it was still very tough for me. Well, Amit, one of my students, he was the same way. And he says, I'm extremely grateful to have found you in your courses last year. I used to feel imposter syndrome. When I started working, my skills were lacking compared to others, and I always felt like I had a lot to catch up on. Now I feel like I belong and can take on any new challenge. I would not have my new job if it wasn't for you, and I will always be thankful for that. In short, you have changed my life and the direction of my career. He also, when he got his job at PwC, they're one of the big 4 consulting companies, he actually shared with me his the report that he put together. And this was amazing. I mean, he really like wowed me with it. He said, this is what helped me move into the final rounds. I was able to do everything within 2 days. And if it wasn't for your courses, it would have definitely taken me longer. And my results would not have been half as good to move into the final rounds. So really powerful stuff. And I'm not lying when I say the time series course has literally gotten people jobs. Amit got him his job. There's been other students that I've had on my coaching calls that have talked to me and are like, yeah, man, that time series course is no joke. So today you guys are getting Data Science for Business Part 1, Part 2, and my high performance time series course, total value $2,637. Now, next on the path is building tools for yourself. For that, I have Shiny Apps Part 1. And this is really, it's so important of a course because you need to be able to build a portfolio. You need to be able to impress people, and you also don't want to give people your code. You don't want to give companies code for free. And a lot of people just like link to their GitHub repos, and that's not the right way to do it. What you want to do is you want to build an app. If you're trying to get a job, or if you're trying to impress somebody, say you've already got a job and you want to impress them, and this is how you can build quick proof of concept apps with Shiny Web Apps Part 1. Perfect for portfolios. So in this course, you learn the foundations of production for data science. You learn how to build web applications, and you learn how to automate key business analysis and processes, and empower your company to make data-driven decisions for years to come. This is the first app that I teach you how to build. And this is a special app because it does something that all companies want. They want to be able to get this red line in here. That's the forecast. And it's an on-demand forecast, which when they click these buttons over here, it actually generates a new forecast model on demand very fast, and it produces that forecast. So that way you don't have to predetermine what forecasts are available. You can let the user decide, and that's pretty powerful. The second app that I teach you how to build is the pricing optimization tool. And I actually used to do this because at one of my previous companies, they always would pricing products was a manual process, and that leads people to like make errors because they just type in a price because they look at like the next couple closest products. But when you do that, you end up losing out on a lot of money because you could price some of these products higher, and it's just in the products that you price too low, you lose money, and then if you price them too high, then the demand diminishes. So it's a lose-lose situation. But with a tool like this, that can help companies more accurately price their products. So that's the second app. Again, what does this course do for you? This is Habby. This is what it did for her. So this Habby's a student of mine, and this is the first app, the first Shiny app that she has literally ever built. She made this for her data science portfolio. It's a S&P 500 top 10 tech companies, and she had never had a job before. And she landed her job at the U.S. Federal Reserve of Minneapolis this app is one of the things that helped her get through the interview and really caught their attention. Same thing with Francesc. He was in my program. He made this application and he left my program with a job offer. So today, guys, you're getting Data Science for Business Part 1, Part 2, my High Performance Time Series course, and my Shiny Web Apps 1 course. Total value, $3,516. And then last on the path is building tools for your company. So with Shiny Apps Part 2, this is where we really teach you the skills that are going to help accelerate you through your career. So a lot of people are just focused on just getting a job, but like what happens after that? Well, what companies want is they want to have people that grow with the organization, become senior data scientists, lead data scientists, principal data scientists, and beyond. So to do that, you need some more advanced skills. And this is also what helps the company really develop their enterprise grade applications. So to do that, you need to learn cloud technologies like AWS and Docker. You need to learn how to scale and deploy data science. You need to learn how to add security authentication. That's a requirement for the enterprise. And connect backend databases, customize the user interface, integrate an API. Basically, in this course, you learn everything that you need to deploy applications in the enterprise. Okay. The cool thing is you don't just build a multi-user app like this one, but you actually deploy it using AWS cloud technology, Git and GitHub for production code, and Docker and Docker Hub for the production environment, which are the exact same skills that companies pay data scientists $150,000 or more a year. So to prove it, this is what Mohana said after he completed this course. He actually sent me this testimony. He said, you know, after your entry into my life, in just another 6 months, I was getting these 3.5% raise hikes. But after that, I got a 10% hike. And then another 6 months, I got 26% hike. And then another 2 months, a 40% hike. He says, I could grab a job wherever I want. So that's pretty cool. That's pretty game-changing and life-changing, you know, financially for him. And he's, you know, super happy because of it. This is the type of application that you build. And so what you're getting today, guys, Data Science for Business Part 1, Part 2, my High Performance Time Series course, Shiny Web Apps 1, Shiny Web Apps 2, total value of $4,395. Now, what about projects? This is a common question I get. You do complete 8 end-to-end projects throughout this program. So you complete a customer segmentation in course 1, product price prediction in course 1, $5 million churn prediction in course 2, $5 million demand forecasting in course 3, demand forecasting app in course 4, product price recommender app in course 4, stock analyzer app in course 5, and an application library in course 5 as well. And what that does is it houses your 3 apps that you built. So you've got a portfolio, literally, that you leave this program with. What about lifetime support? So let me show you this. This is the actual Slack channel. So this is the Slack channel that you guys get access to. As you can see, if I go to something like announcements, we have 3,266 students in here. And we got tons of people, you know, asking questions, you know, talking. Give you an example. Here's one that I was working with. I'm helping this one through a problem right now. This is Chris. He just sent me his Shiny app that he's putting together. I'm helping him get that up and running. So this is the community that you gain access to. And this is what helps you get through those problems that you're going to eventually run into as you're becoming a data scientist. All right, so that's the Slack channel. Next thing, what results can I get? Well, here's what happens when you join the path. So this is David. He says, your courses gave me the confidence to get through the interview process. He got a job at Microsoft. This is Justin, and Justin was amazing. He came from academia and he pivoted, making a whole career pivot into working with a financial company, an insurance company called Northwestern Mutual. He says, in less than 6 months, I had fully transitioned into a lead data scientist. He's actually the principal data scientist for them now. He's also working on my Pi times EK package. This is Ben Win Morris. He says, after 5 years of struggling, I now have 2 job offers. And this is Jennifer. Jennifer's awesome. I met her at a conference and she was learning Python, and she had been, I think, 2 or 3 years into learning Python, and kind of like the imposter syndrome, you know, affected me. I could see she was deeply affected by it as well. And she said, you know, when I'm doing Python, I don't even know where to start to solve the new a problem that I'm working on. And I asked her, when I met her, would you be willing to give R a try? And she said, let me think about it, because you'd put so many years into Python. And she messaged me a couple of months later, and she said, hey, I'm ready to give it a go. So we got her into the program, and she says, thanks to Matt and what I've learned so far, I was able to do an in-depth analysis using my business science problem framework and complete the project using R Markdown. Says the polished finished product impressed the hiring manager so much she was willing to fast track an offer. She got her dream job at VP of Strategic Analytics at JP Morgan Chase. I mean, that's nuts. After suffering from imposter syndrome to literally 3 months later having the job that she wanted. Now, I'm going to give you guys a special advantage, though. So everybody that you've seen here today did not have the offer that I'm going to give you guys. All right. So to reward the fast action takers, I'm going to give the first 10 people that take me up on this offer a free one-on-one call with me. All right. And that's really important. Here's why. So this is Samantha. She used her one-on-one coaching call to get through the 3rd round of the CVS pharmacy data scientist interview. And she says, I got the job. So literally she wiped the floor with her competition. We put together a strategy. We met on a Friday. And by Monday, she told me she got the job. She put this in our Slack channel, and she's now the R-Shiny data engineer at CVS Health. So that's what that coaching call can do for you. So you guys today are getting Data Science for Business Part 1, Part 2, my high performance time series course, Shiny Web Apps 1, Shiny Web Apps 2, and a one-on-one coaching call with me. So the first 25 people will then get a special bonus called the Lost Time Series modules. So after I had built the high performance time series course, I started to get a bunch of questions that, and there were a few that kept coming up. So I had to build a lot of software and some additions to model time. And what I did was I built some modules to discuss how to do those in depth. So the first one is recipe 1, changing demand. So what happens when we're forecasting in a recession or when COVID-19 happened? I give you strategies on how to do that. Second one is the iterative forecasting without for loops. So in the main course, I taught how to do global models, which are really powerful and they're really fast. But the iterative forecasting can be more accurate. And what I did was I came up with a system to do it without for loops, and I integrated that into model time. The next one is recipe 3, autoregressive forecasting. So this is really powerful when you're forecasting at a monthly or a quarterly level where you don't have like timestamps that you can like extract information from. So this shows you how to put lags into those forecasts and integrate those in an iterative forecasting situation. The next one is automatic machine learning with H2O. Teach you how to take the same thing that you learned in the second course and now turn it into a forecasting solution. That's pretty cool. And then recipe 5, which is really powerful for companies like Walmart, Kohl's, Target, any of the big retailers, any of the energy companies. They deal a lot with this problem called hierarchical forecasting. So what that is you've got like, a hierarchy or hierarchical structure in your forecast, and you need to be able to forecast those at a very granular level. So you can see here, we're dealing with one product, and it has a problem called intermittent demand. So I show you how to deal with that in this particular recipe. So what does this course do for you? This is Jeanette. Here's what it did for her. She got a job offer from the Bank of Canada as a data scientist. And the surprise was, whoops, oh man, I flew through it. She created a Shiny app forecasting after taking this course, and they created a higher position for her. And she says the whole team are Python programs, but what set me apart and helped her stand out was the Shiny app that she built following this course. So today, guys, you're getting Data Science for Business Part 1, Part 2, my high performance time series course, Shiny Web Apps 1, Shiny Web Apps 2, a one-on-one coaching call for the first 10 people, and then the Lost Time series modules, a total value of $5,894. Now, I recognize too, one of the biggest things that people have been requesting from me is for how do I use ChatGPT to help me speed up becoming a data scientist and help me speed up making portfolio apps and doing those sorts of things. So I created this special bonus called ChatGPT for data scientists, which comes with 2 modules. The first one is part 1, which teaches you how to avoid the mistakes that I made during the first 3 months of my journey into ChatGPT. And then the second one, super powerful, teaches you how to build applications 10x faster. And I actually give you a really cool app in that one. So the first one, again, is you get all the code shown in the learning lab that I did on this one. And then this teaches you all of the mistakes, how to avoid them, and how I overcame them. And then the second one is where you get a powerful ChatGPT workshop that shows how I 10x my journey and my speed of building these web applications with ChatGPT. And I show you exactly how I build these apps so fast with ChatGPT. All right, so today, guys, you're getting Data Science for Business Part 1. Part 2, my high-performance time series course, Shiny Web Apps 1, Shiny Web Apps 2. And first 10 people are getting a one-on-one coaching call with me. And that's a 60-minute coaching call, by the way. And then the Lost Time Series modules and the ChatGPT for data scientists, a total value of $6,393. Now, if you're buying this today, on my website, it would really add up to this amount of money if you bought them all separately. And I realize, that's maybe a lot of money for some people, even though it's worth every single penny compared to college education, which is like $100,000 or more per year these days. So instead of paying the $6,393, I'm going to give you guys a 66% discount. All right. So instead of paying $6,393, you're going to get it all for $19.99 today. Now, the last time I announced a sale like this, we did sell out of the coaching calls on the first day. So for those of you who want to become a business scientist, are you ready to change your life? All right, ready, on 3, 2, 1. All right, I'm putting it in the chat here, guys. I'm going to put the link to sign up. And as you guys get signed up, I'm going to just briefly, I'm going to take some questions from you guys. I've got about 30 minutes for questions. And what I want to do first, though, is walk you through the process for signing up. For those of you who want to take me up on this offer, it is an amazing offer. Again, by the way, it's my 2023 data science career deal. The offer does go away in 2 days, so it'll be gone. And then next year, it's probably going to end up going up in price just because of inflation and everything. But as we had discussed, you've got the 5-course R track that you're going to get. So these are all 5 courses that you will get. You're going to get bonus number 1, the Lost Time Series modules, those 5 additional time series recipes that are more advanced, that teach you how to do some of the key things that companies really want from their time series experts. Bonus number 2, how to use ChatGPT more effectively to help you improve yourself as a data scientist and just get stuff done faster, basically. And then bonus number 3, one-on-one career coaching call with me. You can use that like Samantha did, for the coaching and wipe the floor with her competition, or you can use it for anything else. I've got experience as a business consultant. I've got an experience solving data problems. If you've got a big problem that you're working on at work, I can help you through those things too. So there's a couple different ways you can use it. So everything that you're getting today, guys, Business Science Part 1, Part 2, High Performance Time Series course, Shiny Web Apps 1, Shiny Web Apps 2, Lost Time Series modules, ChatGPT, and the one-on-one coaching call. All right, it is limited to 10 people. I only have so many slots available on my in my schedule, and I'm only able to take on 10 new coaching calls this time around. What you're going to do, if you're interested in the offer, which I do hope you are, it's an amazing journey. You're going to love it, and I'm excited to work with you. What you'll do is you'll enter your information in here. So you'll put your full name. So that's your first and last name, then your email address. And the reason we need this stuff is it's going to connect you up with our platform that I'll show you here in a minute. And we ask for your phone number here because in case you ever have any problems, we can hop on a phone call with you, get everything sorted. If you have a problem installing the software, we can reach you and we can get you up and running. The next thing, there's 2 different payment options. So the first one is what I would say most people take. It's the 5-course R track, the single payment plan, as we had discussed, $19.99. Why do most people take that? Well, because as we had discussed at the beginning of this is Learning Lab 89, and I have 89 labs. So you have a special offer that can only be added to the $19.99 plan. And that gives you unlimited access to my entire lab vault of 89 labs. So when you want to make data science projects, make a portfolio, ace a data science interview, You can get access to those here. It is a subscription, but you're getting 30% off of that monthly subscription. And you can only add this onto the $19.99 plan. If you select the payment plan, you have to unselect this. All right. So it'll give you an error down here if you try to proceed with that. So a big benefit here is if you want Learning Labs Pro at a better rate, again, people on the website, they spend $69 a month on Learning Labs Pro, and that's what most people, everyone who buys on the website, that's what they pay. So you're able to get it for $49 a month here. All right. Okay. Then you'll just enter your information in here. Once you click the complete the order button, what's going to happen, give it a minute or two to process. And what's going to happen is you're going to get an email, a confirmation email, and a welcome email that sends you to our, that gives you the link to both join our Business Science University and also our Slack channel. So this is the Slack channel that I had mentioned previously, where we have 3,266 people on the same track as you. So it's going to give you instructions on how to do that. Also, this is what the platform looks like. So it's going to give you instructions on how to get logged in for your first login. If you do Learning Labs Pro, you'll have this here. You'll have these 5 courses, plus you'll have the ChatGPT course. You'll have the Lost time series modules. The only thing you won't see is a coaching call, but you'll get a separate email if you're one of the first 10. That'll help you with the process of booking that call. You don't need to book right away. That never expires. So nothing that everything you get, you have lifetime access to, with the exception of the Learning Labs Pro. If you do the monthly membership, you have to pay monthly for that. But that's just because I keep adding content to it. Okay, so that's how the courses work. What do the courses look like? That's the next common question I get. This is what just one of the courses looks like. I mean, there is literally so much content in here, it's ridiculous. This actually, I don't even think I went to the end. Yeah, here's the end. You're doing the 2 project reports, but each one of these videos is very small, bite-sized. You're able to really just kind of digest each of these. 8 minutes is actually a long one. Most of them are like 2 to 5 minutes. And here we'll go to here's what it looks like. You can see the videos, they're crystal clear. If I increase to full screen, you can see, we're actually doing line by line coding, and you're really doing data science with me. Like you're coding along with me. The format is awesome. It's what I wish I had when I was learning, to be honest. So that's the way each of these courses are structured, tons and tons of content. And with that said, I'll get back to it, but that's how the system is set up. And hopefully I've answered a few of your questions. I will put the link in the chat one more time, and I'm going to start to answer some of your questions now, because I know you guys have been patiently waiting. So what questions do you guys have? I have another 15, 20 minutes here. We can, before we wrap things up, I'm going to go off of the webinar chat. So if you have your questions, just put it in the chat, and we can talk about them. So Adrianus asks, I didn't get how long we have access to the courses. So yes, all of the courses that you get access to here, the bonuses, you have lifetime access to them. Okay. So each of these courses, once you pay once, you have lifetime access. If you do the payment plan, you also get immediate access to everything, which I know is kind of crazy, but you do. I want you guys to have access to it. Bonus number 1 is the Lost time series modules. You have lifetime access to that. Bonus number 2, ChatGPT, lifetime access. The one-on-one career coaching call, you actually have so you get one call with me, and it's 60 minutes. We can use it however you want. Most people use it for the career strategy and trying to figure out how to get the data science job of their dreams, but you can literally use it however you want. That never expires. So you do get one of those, but you can use it like next week. You can use it in 6 months. Doesn't matter. You can use it when you need it. Let's see. What is the 5-course payment plan $199? Please explain. So that's Shweta. So the payment plan. Okay, so there is a payment plan. So again, how it works is if you do the single pay, That's $19.99. If you do the payment plan, it's 12 payments of $199. So, but the problem with that is if you want Learning Labs Pro, you have to unselect it. You cannot get that, and you're going to have to pay if you want Learning Labs Pro to get the recording, to get all the code that you just saw, and all the other labs too. You're going to have to buy that on the website, and you're not going to get the $199 or the $49 a month rate. So you have to remove that if you select the payment plan. If you do the full pay, you can then add Learning Labs Pro on for the discounted rate of $49 a month, which is amazing because I routinely have people saying that they learn just as much, if not more, from Learning Labs Pro as they do the 5-course R track. Now, of course, the 5-course R track is what they need to get their foundational skills and really learn, business problem solving, time series at a deep level, and shining and making production, taking data science into production at a deep level. You don't learn that in Learning Labs Pro, but you do get lots of project experience through Learning Labs Pro. So it is a recurring payment. So it'll be a monthly subscription. So you get 30% off that monthly subscription. And every month, so this month I have 2 Learning Labs coming out. I have this one, which you just witnessed today, and you saw how powerful that was. And then I have an even more advanced one that's coming out in 2 weeks, which we're going to start doing causal ML, and we're going to start doing some of the more advanced techniques that we're actually going to learn how to take that hotel problem and create an experiment where we send people emails and we have them try and opt in, get them to opt in and see if there's a lift. So this is, Learning Labs Pro is pretty insane. And if I was purchasing a program like this, which I have purchased even more expensive programs, I purchased a $5,000 one like in 2018. And the crazy thing is, this is what I wish I would have had. That is no joke. This system here is insane. So yeah, you get lifetime access, and the Learning Labs Pro is the only thing that there is a payment plan associated with it. Okay, so hopefully that answers that question. Udit asks, what's the duration of the course on average? How long will it take full-time for a full-time professional? So I've actually designed these courses for a full-time professional. So when I was learning data science, I was doing it in my spare time, basically. And that's why it took so long. So the idea here is I basically streamline the entire process. Now, it still will take a little bit of time, but that doesn't mean that you need to wait. So this course here probably would take you like 4 weeks to 6 weeks to complete that. This one, tack on another 4 to 6 weeks, and 4 to 6, 4 to 6, 4 to 6. And that is kind of the general, if you can do, I would say 10 hours a week, it'll be more like 4 weeks per course. But if it's like 5 hours a week or less, then it's going to be more like 6 weeks per course. But the key is that you don't have to wait until you complete all of them to apply for that data science job or get that promotion. So what I highly recommend is taking the courses in this order. And what you'll do with this course is get your foundations, then you'll get the BSPF. You learn how to do the business problem solving, and then you learn how to do a really niche skill that it's going to set you apart. And as you build just these first 3 courses, that's going to be enough to get you probably just a beginner or an entry-level data science job. Or if you're transitioning from a career, it's going to be enough to demonstrate that you know data science along with whatever your core competency is. So if you're in marketing right now and you want to apply data science to marketing, these are going to be the courses that are going to help you build that skill set that's going to impress the hiring manager. And then the web app stuff is going to help you, obviously build your portfolio, make the things that are really going to grab their attention. So this one right here, definitely, if you needed to get a job in 2 days, in 30 days, I would cram this one in, and then immediately as you're taking on interviews, do this one and then this one to really stand out. And then this one too, I tack on because it helps you then become a senior data scientist. And I know that's, where you eventually want to end up. So That's kind of, all said and done from start to finish, figure like 6 months or so, at 4 weeks of course. But, everyone's got their own pace. You have lifetime access. Don't feel like you have to, cram it all in, unless, you're really trying to to get that job or to get that promotion or to transition into data science. All right. Does that answer your question, you did? I know that was kind of like a long-winded response, but I wanted to explain my thoughts. All right, cool. Frederico, thank you, Matt, for your clarity and passion and inspiration as per how professional and yet friendly your communication is. Oh, you're welcome. You're welcome, Frederico. Christian asks, what package is used for causal ML? So causal machine learning is, we're going to talk more about that in the next presentation. So that'll be coming in a couple of weeks. There's actually a Python package that I'm going to show you guys how to use. And it's, but I still have to develop that whole problem and everything. So let's table that one for now. I'll answer that in a couple of weeks, I guess. All right. Ken asks, will access of learning labs be lifetime? So I don't normally offer that. That's the monthly recurring payment plan is the only offer that I have available now. Sophia asks, do you have a course that follows this workshop? Well, this is actually being recorded. So at the end of this, I'm going to process this recording and it'll go into Learning Labs Pro. That's this thing right here. So if I open that up, what Learning Labs Pro is, it literally is a vault that has all of the labs that I've done. So I just did ones on price elasticity and optimization. This one's in Python, this one's in R. Here, I'll open this link just to show you what it looks like. So this is the structure of how the labs. So this is the recording that gets put in here. So you get the recording, the full recording, which is like, an hour and 26 minutes long. Table of contents of everything that I cover. You get the code that you can download as a zip file and the slides also that you can download for your reference. So it does become a course, and it's just like it goes into Learning Labs Pro. And you can see here we've got 89 of these labs. I mean, there's like, this is huge. And each one of these are like an hour plus of training. Okay. All right, good questions. So let's see here. Just going to do a quick time check and also see how many coaching spots are left. All right, so we got 1, 2, 3, okay, 4. Okay, Kevin just joined. We got Doug that just joined. Let's see. All right. So we got, looks like 6 people just joined. That means we have 4 coaching call spots left. If you guys want a coaching call, what questions do you have for me if you're on the fence? So please let me know if you're in the chat, if you've got a question, if you're interested in the program. We only have about 10 minutes left or so. And those 4 coaching spots, they'll probably be gone by the end of this call. Oh man, talking a lot. All right. Well, any questions that you guys have at the moment? Is there any trial period for the course? So you did. This is a good question. There is no trial period, but you have a 30-day 30-day money back guarantee that if you find, if you're dissatisfied with it, just let me know. So that's kind of like the trial. You got that first 30 days. You do have to pay for it up front, but if you ever have any issues with it within that 30 days, just let me know. You did ask how tough or challenging the course can I get since I'm mostly into SAS. If you've already got SAS experience, I mean, that's actually pretty good. A lot of the students are really coming from Excel that I'm seeing, like a lot of analysts, they're maybe using Tableau or Power BI. So SAS, you actually have a little bit of programming experience, and that's going to be really powerful for you. It's also, I hear from SAS people, it's a lot easier of a transition to R. For whatever reason, it just seems like the workflows are easier. So it's I've designed this system so that way it's like, no coding experience. If you haven't ever coded before, that's okay. I was there with you. This is the program that I wish I would have had when I was starting my journey that I never had. So this one will teach you all the coding stuff that you need to know, how to do the basics of programming, so you can start to get some business results. This one will teach you how to solve the business problems and give you layers on the more advanced stuff. And the way that they work is they actually build you up. So everything that you learn in this course, you don't have to relearn in this course. You can just get right to the next step in your progression. And then the same thing with this. Like if you take this course first, this one becomes so much easier because you already have the foundational skills, and we don't have to rehash that. And that's just how everything kind of builds on each other and makes it a lot easier. So does that make sense to you, Dip? Yeah, I know you've had a couple of questions in here. I want to make sure I help you. Okay. Sophia asks, how can I sign up for the place that has the recorded workshops? Good question. Learning Labs Pro. All right, so you can sign up here for that, but just recognize that you won't get a discount on it. Okay. Okay. Let's see. So I'll put the link in the chat one more time. Just make sure I got all the questions answered. Oh, man. All right. We did have one more sign up. So we have 3 left, guys. 3 left. Peter asks, I am torn between learning R and Julia and don't have time to master both. What makes R a better choice? So I've dabbled a little bit in Julia. Julia is fantastic. It's a high performance language. But what I will say is that the ecosystem in R is much, much more developed. Now I know that they are building Tidier JL, which is the Julia port of R, R's Tidyverse. But honestly, you're going to have a lot more of a ecosystem for doing causal inference. None of the packages are available in there for causal inference. When you want to do time series, none of those packages are available in Julia. So you're going to have to code all that stuff from scratch. And that is, in my opinion, it's just too early, in my opinion, to have Julia be your number 1 language. I would focus on probably R if I was you. Again, I am biased because I've dedicated my life around learning R and developing R stuff, but that's kind of the progression that I would go through in my thought process. Okay, does that make sense? Yeah, Julia is great. I mean, I see Esteban, so yeah, a lot of economists use Julia, but again, you might be, in my opinion, there's just the ecosystem. It's all about the ecosystem, and R has quite the advanced ecosystem. Beverly asks, when I sign up for the Learning Labs Pro, will I have access to the past sessions? Yes, you get access to everything, actually. You get immediate access if you do Learning Labs Pro, so that's this thing. You get access to, where was that? All of these Learning Labs in here. And it's a ton of content. Yeah, you get access to it. Okay. All right, let's see. What other questions do we have? So Peter, we answered yours. Okay, Beverly, we got yours. Who else has any questions? We have just a couple minutes left here. I'm gonna yeah, we're gonna wrap this up in probably a minute or so. I think this timer got stuck. So anybody have any last questions? Otherwise, we're gonna close this thing out. Okay. All right, going once, going twice. Cheat sheet. Okay, we'll do the cheat sheet now. All right, copy the link address, putting that into the chat right now. Here's the cheat sheet for everybody. Here is what the cheat sheet looks like. I'll just show you kind of what you're getting, walk you through it. So I just put the link in the chat for the cheat sheet, and this is the way it's structured. So there's 3 different pages. Each page covers something a little bit different. So this is the 80-20 workflow. So if you think of like the Tidyverse, These are all the core Tidyverse packages. And if you want to get to the documentation, you just click one of these links and it'll take you to the documentation. If you see a CS, like for dplyr, it'll actually pull the cheat sheet up, and you can get access to the cheat sheet as well for each of these specific packages. The second page is for the Shinyverse. So there's actually kind of like an ecosystem around Shiny, which we talked about a lot in this towards the end of the presentation. But Shiny is a really powerful tool for building web applications. And this is kind of the workflow that I go through for developing and deploying Shiny apps. And then on the last sheet, this is where we talk about, at the beginning of the presentation, when I said, these are all the different kind of like niche skills that companies want you to have, things like time series, text, network analysis. These are the packages that I use in those particular scenarios. So that's what you get in this, and it's got links to everything. So enjoy. Any last questions before we wrap it up? Otherwise, we can all have a good day and happy Wednesday, and I'll see you again in a couple of weeks. All right. Thank you guys so much. I will see you guys soon. Oh, remember, there's 2 more spots left, or I think 2 or 3 more spots left for the coaching calls. So if you want one, make sure you hop on that link. I'll throw the link in the chat one more time just for you guys. Here's a link, and I will see you guys again soon. Just put the link in the chat. Grab it if you need it. All right. I'll see you guys soon. Bye-bye.